This is Geometry, Semester 2. It is a unit congruency review, number 12. It's the second lesson, angle, side, angle, HL practice. It's on creatormath.com under the Geometry tab. You might have to Google creatormath.weebly.com. It says copy the following problems into your composition book on the correct pages according to the table of contents with the notes for those pages from creatormath.com. As a very quick aside, so let's just show really quickly, creatormath.weebly.com. Here's what the home page looks like. There it is. All of the notes for geometry are under the Geometry tab. You'll see the vocabulary first, which you need this PDF to do all your vocabulary work. Skip by that. Go straight to the table of contents right here. This should have been copied onto page 2 through 6 of your composition book a long time ago. If not, copy it in now. Let's scroll down to the unit we're on, which is Congruency Review. And it's way down here. There it is, Congruency Review. This is lesson number 2, AAS and ASA and HL Congruence Postulate. Here are the pages that the notes go in your comp book. The notes will be on this tab here. The problems we're going to go over are here, and the video solution we shoot right now will be on this link. So please follow the page numbers from the current table of contents, not this video, because they will be different by the time you watch this video. So are these triangles congruent? If so, why or why not? So we've done other lessons on congruency. This is a review lesson, and this is the second review lesson. So I'm going to move rather quickly, and we're going to go straight to whether we can tell if these are congruent or not. Congruent is multiple aspects of equality. It looks like we've got two triangles. They share a side, which means this side is the same for both triangles. It looks like an angle right here. And if this is 90 here, this has got to be supplementary. This has got to be 90 here. Supplementary means they sum to 180. The hypotenuse leg congruency postulate. So there is one for right triangles. If we have a hypotenuse that's equal to another hypotenuse, and we have a leg that's equal to another leg, and these tick marks tell us that this hypotenuse here is equal to this one. So they are corresponding parts of different shapes. Corresponding means they're in the same location on different shapes. And we have a leg here. This is one of the legs because it's attached to the 90. A triangle has two legs and a hypotenuse. And we always say two legs like a human, trying to remember it. So this is the special hypotenuse leg congruency postulate. So yes, they are congruent. These two triangles are exactly the same. And congruency means equal. We don't use equal because it's multiple aspects of equality. Not just the angles are equal, but the side lengths are equal too. Assuming the following triangles are congruent, what's the proper notation? So they start with triangle ADC. So triangle ADC. Track that through. ADC. We must now say congruent. Here's the congruency symbol and equals with a squiggly line over it. We're going to match it up with this other triangle, and we want to go in the same direction. Because we went ADC, we're going to go BDC. Because what we're matching up is the corresponding angles. The corresponding angle to A is this one over here, B. The corresponding angle to D on this one is D on this one, right? And the corresponding angle on this one, C. And we don't even define these very well. It's just the points here of the vertices. So BDC. They're just helping us with notation. Assuming the following triangles are congruent, which side corresponds? So that's the same location on a different shape is what corresponding or correspond means. So let's look at AD. If AD is the side on this shape, the corresponding side is going to be, and we're going to go the same direction. We went AD here, so we're going to go BD here. BD. Are these triangles congruent? If so, why? So let's start to look a little bit closer. We have two. Now, don't look at the way they look. They look congruent, but I need to look at the tick marks. Here's a tick mark of this angle. Those two angles are, let's call them corresponding, the same location but on different shapes, and they are equal because of one tick mark. This side is an equal length to this side. Those tick marks tell us so. And a double tick mark here tells us that these two angles are equal. Well, yes, these are, because we have a congruency postulate called angle, side, angle, ASA congruency postulate. Angle, side, angle of this triangle is equal to the angle, side, angle of this triangle. So the two, therefore, due to the ASA, the angle, side, angle congruency postulate, are congruent. Are these triangles congruent? If so, why? So let's track through this one. Let's start somewhere here. And they look the same, but what do we got? We got an angle equal to an angle. We got another double tick mark here, an angle equal to an angle, and we got a side equal to a side. But this is angle, angle, side. So do we track through the same direction? Angle, angle, side? Yes, we do. So we can use the angle, angle, side congruency postulate. And the hard part may be for students to just remember all the different congruency postulates. And maybe this worksheet helps you kind of nail down some of them. And check the notes for that too, which go on the correct pages in your comp book. Are these triangles congruent? If so, why? Well, we have the HL congruency postulate, the hypotenuse leg. So this is a 90-degree triangle. We know that because these both are. We then have a leg. This is a leg because it's attached to the 90. This is a leg because it's attached to the 90. It looks in a corresponding location. And we have a hypotenuse here that is equal length to this hypotenuse. So we have a hypotenuse leg of a right triangle. So it's the hypotenuse leg congruency postulate. The HL congruency postulate only works with 90-degree triangles. All right, this one's pretty quick, not too bad. So this is just to orient you. They're on creatormath.com under the Geometry tab, and it's Geometry Semester 2. It's the 12th unit called Congruence Review. It's the second lesson called AAS, ASA, HL, Practice. That stands for angle, angle, side, angle, and hypotenuse leg practice. All right? Hope this helps.